Hi, good to see you again. Welcome to Block 5, Addition and Subtraction of Fractions, Lesson 2. I'll share my screen. So in your previous lesson, you learned how to represent fractions as diagrams, which helps you really understand the concept of fractions, how things divide. In this lesson, you're going to learn how to convert between mixed numbers and fractions. It's a very important concept. In fact, students find it very confusing. So we'll first use diagrams to understand the concept, and later on, we'll use just abstract, so just thinking about the numbers to be able to convert between mixed numbers and improper fraction, and then do it the other way around, improper fraction to mixed numbers. Remember to like the video, share the video with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you for supporting our mission of educating a global population of children who may not have access to high quality maths education because of their economic circumstance. So help a child, provide free internet access, and let them learn. Before we start, I would like you to pause the video and do the retrieval practice questions in 2 minutes. Here you ask what fraction of the bar is shaded, what fraction of the bar shaded is blue? The fraction that is shaded is 3/5. It's obvious. And then here you asked how many, so for this one, you ask what fraction of the bar is shaded, that is green, is 8 out of 8. So 8 out of 8 bars are shaded. Next, you ask how many parts are yellow. Of course, we can see that 5 parts are yellow. That's all they've asked. How many parts are yellow? 5 parts are yellow. Okay, let's do some new learning. If you asked how many parts are shaded, of course, you would say 2 parts there, and then that's the third part. Now, when we represent fraction, the parts in which the diagram is split into is what the denominator is written as. So if you have a diagram that is split into 4 equal parts, your denominator is going to be 4. If you have a diagram where the parts are split into 5 equal parts, your denominator will show 5. So remember, the number at the bottom is telling you how many parts the shape has been divided into. So in this case, we have divided the shape into 2 equal parts, but it happens that out of the 2 equal parts, there is also another part. So altogether, the number of parts that are shaded are 3. So we have 3 out of 2. Now, this is called an improper fraction. Why? A proper fraction usually has, or a proper fraction has a smaller number in the numerator, which is the top number, and a bigger number at the denominator, which is the bottom number. So this is an improper fraction. So this diagram here represents 3 over 2. So I hope you know how to now interpret between a diagram and how to represent that diagram as an improper fraction. So an improper fraction is where the numerator, the top number, is bigger or greater than the denominator, the bottom number. Now, this fraction, if we want to represent it as a mixed number, it's going to be 1.5. Why? We have a whole that is shaded and a half that is just shaded. So if we represent this as a mixed number, this represents a whole and a half. So this is a mixed number. What is a mixed number? A mixed number is a number that has a whole, the 1 is the whole, and a fraction written beside it. So this is a mixed number. But how do the representations show mixed numbers and improper fractions? Well, let's consider this. If you look at the number line, you can see that this part is divided into three intervals. So you have 1, 2, 3. And you have between 0 and 1, if we want to divide 1 into those three parts, the way we normally label intervals, which you should know from our previous lesson, each of these is 1/3. That should be 2/3. And that should be 1/3 because we're adding a third every time. Now, if we think about the improper fraction form of this, we would see that that should be 3/3. 3/3 is 1, and this should be 4/3. So we're beginning to explore the relationship between improper fraction and mixed number. What about this one? You can see that these have different shapes shaded. Okay, sorry, different parts shaded in this shape. So if we put them together to try to, put them together, we would have this. So we happen to have a whole shaded. But take note that we have 1, 2, 3, 4, 5, 6. So remember what we said, that the number of parts in which a shape is split into is the part that will be in the number that will be in the denominator. So when we write this a fraction, we would have 6 in the denominator. Now we have a whole that is shaded. So if we want to write this, we'll say we have 6 and then we have 4. So we have 10 parts shaded all together. And then the denominator will have to be 6 because we have the shape split into 6 equal parts. Now, how would we write this as a mixed number? You can see that the whole is shaded here. So that is 1. And then you can see that 4 out of 6 is shaded. So we'll write 4, 6. And of course, you can simplify this if you want to, but we don't really need to. Let's keep it that way. So we could have simplified this if we wanted to, but let's keep it that way. But if we look at the cylinders, both the ones that are full and that are half full, we would say that 2 whole are shaded and then a half. But if we want to represent this as an improper fraction, imagine if we had to split these into equal parts the way we've been splitting the others, even though they're shaded whole, we would have 5 halves. So we have a half, a half, a half, a half, and a half. So we have 5 halves, which is 5/2. All right? Now, how do we convert the improper fraction to a mixed number? How do we convert an improper fraction to a mixed number? I'm going to show you using this diagram, and then we'll look at another easier way of doing this. So I want you to pause the video and have a think at how we can convert the improper fraction that you see represented in this diagram into a mixed number. Well, I'm sure you've had a think. So here we have, what do you think will be in the denominator? You can see that we have this shape split into 1, 2, 3, 4, 5, 6. That's right. I'm sure you've said 6 will be in the denominator. And then, how many parts are shaded? Well, you can see that 23 parts are shaded. 23 parts are shaded. So we have represented this diagram as an improper fraction written like this. But how do we convert it into a mixed number? Remember that we can count the number of holes. So we have 3 holes, and we have 1, 2, 3, 4, 5. 5 parts shaded out of 6. So I'm sure you can now see how to relate or see the connection between a diagram and the improper fraction and a mixed number. Now, let's look at something else. Here, you can see clearly that this diagram is represented by this mixed number. So let us see how to convert from the mixed number to an improper fraction. So see that the diagram is divided into 4 equal parts. Of course, that's why we have 4 in the denominator. But see that we have 2 here because 2 whole are shaded. And here we have 1/4 because just 1 out of the 4 is shaded. So this diagram represents 2 whole and 1/4. But if we want to convert it an improper into an improper fraction, we have to consider the number of parts that are shaded. We know the denominator will definitely be 4. So let's look at the total number of parts that are shaded. We know that 4 out of 4 are shaded, plus another 4 out of 4, and 1 out of 4. So altogether, we have 9 out of 4. Another way of doing this is we could have simply counted the parts that are shaded, and then write it out of the denominator being the number of parts the shape is divided into, which is 4. It's now time for you to pause the video and practice what you've learned. Pause the video and answer questions 1 and 2 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So for question 1, you were asked to circle the mixed number. By now, you should know that the mixed number is a number that has a whole number written with a fraction written beside it. Then you're asked to circle the improper fraction. The improper fraction is a fraction that has a bigger number in the numerator compared to the denominator. And you can see this one represents that. Pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3, you're asked to write the numbers represented by the diagrams as a mixed number and as an improper fraction. Of course, as a mixed number, you can see that we have 2 wholes that are shaded. We know that we have this divided into 3 equal parts. So we know that the fraction that is going to be written next to the 2 whole is going to be 2/3. And that's it here. Now, if we want to write it as an improper fraction, you see that we have the parts split into 3 equal parts. It means whatever we write must have 3 as the denominator. But count the number of parts that are shaded and you will see that it is 8. So you see that it's 8/3. Another way to do this I want to show you, which you should think about whenever you see this. We're going to see it in the second part of this lesson, but I want to show you another way of thinking about it. So we have 2/3. One way to do this is to say 3 times 2, which is 6. 6 plus 2 is 8. 8/3. I'll repeat. You multiply the denominator by the whole and you add the numerator. That gives you the improper fraction. And then look at this one. You can see that we already have 1 whole. And you can see that this part is 4 intervals. So each of these is 1/4. So it means we have 1 and 1/4. And that's it. You can see, that's what you can see here. Now, if we have 1 and 1/4, I want you to use the method I just showed you really quickly. Of course, you can count the number of parts. We have 1, 2, 3, 4, 5, which is 5 out of the 4 because this is split into quarters. But you can use this quickly. 4 times 1 is 4, plus 1 is 5. So this is 5/4. Here, you can see that this is split into quarters as well. So your denominator will definitely have a 4. Now you can see that 3 wholes are shaded and a quarter. So this is 3 wholes and a quarter. Now, if you count the number of parts, you will see that you have 13 parts shaded. And of course, because these are split into quarters, your denominator has to be 4. Now, another way to look at this, the way I have shown you, is to do 4 times 3, which is 12, plus 1, which is 13 over 4. Here, you're asked to draw a representation of the mixed number 1 3/5. You can simply have a shape that is divided into 5 equal parts, because you can see the denominator tells you the number of parts you must divide it into. And then you can shade all of the 5 parts, which represents this 1, and then shade only 3 out of the 5 parts, which represents this 3/5. So I'm sure you got these right and you're celebrating your success. Pause the video. Here is the answer to part C. You're asked to write 1 3/5 as an improper fraction. This should not be difficult to do. By now, you should know that 1 represents 5 over 5. So one way to look at this is to say 1 3/5 represents 5 out of 5, add 3/5. Or using the method, which is 8/5, or using the method that I've shown you, you can do 5 times 1, which is 5, plus 3, which is 8, so 8/5. Next, you're asked to draw a representation of the improper fraction 8/5. 8/5 means you have to have, looking at this, you have to have, or looking at the mixed number, you have to have parts that are split into 5 equal parts. The denominator tells you the number of parts to split it into. And then, of course, you know you're going to have another group of 5, because you won't have enough to represent the 8. So you shade the whole of the 5, and then you shade 3 more to make the 8 out of the next group of 5. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. Here, the answers are: Philip has been asked to draw a representation of 5/3. Here is his answer. Explain the mistake that Philip has made and draw a representation of 5/3. So Philip has made the mistake of doing 5 lots of 3 split into 3 equal parts. Okay? But what Philip should know is that 5/3 should be, the thirds is telling you the number of parts you must split the shape into. That's correct. But also 5/3, you should know that 5/3 would be, to get 5/3, you'll have to have 3/3, which is a whole, plus 2/3. So we should be 3/3 means shading the whole 3, which is 1, the whole, and 2/3, which is this one. And then you're asked to write 5/3 as a mixed number, and you can see it here, a whole and 2/3. Another way of looking at this to write it as a mixed number, I want to comment really quickly, is to say, if I have 5/3, what is 5 divided by 3? It's 1. My remainder is 2. So I'll write 2/3. We're going to look at this in the next part of our lesson. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. So here you're asked to write the numbers as improper fractions and mixed numbers. So you can see here that these are divided into quarters. So if this is 1, that is 2, that should be 2/4. And you can change it to a mixed number really quickly by doing 4 times 2, which is 8, plus 1, 9, 9 over 4. Here, you can see that this is 1, this is divided into quarters, so this should be 1, 1 1/4, and then 1 1/2. And then you can change it into an improper fraction really quickly by doing 2 times 1, which is 2, plus 1, which is 3, 3 over 2. Okay, we're now not going to use the diagram anymore. So by now, you know how to interpret between the diagrams and the mixed numbers or improper fractions. So let's convert the improper fraction you see here to a mixed number. Well, we know that a quarter means 1 divided by 4. So we want to use the knowledge of what that we know that we can represent a fraction as division or division as a fraction. So a quarter means 1 out of 4. So 32 over 7 would mean 32 parts, of which 7, those parts are divided. We divide into 7 equal parts. You know the 7 represents the number of parts we split the thing into. So if we do that, it means we're going to have this. So 32 divided by 7 will give us 4. And our remainder is 4, which means we have to write 4 out of 7. So 32 divided by 7 is 4/7. Another quick way of thinking about it, remember we don't want to be using the diagrams anymore, is to think about your times table. How many 7s can I get from 32? I can only get 4 7s from 32. Why? Because 7 times 4 is 28. I cannot get any more 7 from what is left. I have 4 left. So I have to write 32 divided by 7 is 4 times. I can get 4 times 7, 4 lots of 7 from 32. And my remainder is 4. And of course, I need to write it out of the fraction, which you have seen why we do it, because of what we know about how to represent mixed numbers and improper fractions as diagrams. Okay, what about if we want to convert mixed numbers to improper fractions? Remember that the 6, the denominator, tells us how many parts we have split the shape into. So it means that this 5 whole means we have 5 lots of a whole shape that is split into 6 equal parts. So it's going to be 5 times 6 over 6. That's what it means, because this 5 means 5 whole. And you know the fraction is, we have the denominator is telling us the number of parts that has been split into. So it means we can say 5 times 6 over 6, which is 30 out of 6, and 1/6, which is 31 out of 6. Another way to do it is what I showed you before. Ignore this and just do exactly as I showed you before. So you take the denominator, you multiply it by the whole, and you add the numerator. So very quickly, 5 times 6 is 30. 30 plus 1 is 31 over 6. So that is a really quick way of doing it. Pause the video and practice what you've learned. Pause the video and answer questions 6 and 7 in 3 minutes. Assuming you've paused the video and you've answered questions 6 and 7, here are the answers. Let's discuss them. So Dan is working out 3/1/4 as an improper fraction. Here is our working out. What mistake has Danny made? Danny simply could have done what we always do. Just simply multiply 3 by 4 to give you 12. 12 add 1 will be 13. So the answer should be 13 over 4 as an improper fraction. Here you're asked to convert the mixed numbers to improper fractions. Very quickly, 2 times 3 is 6. 6 add 1 is 7. 7 over 3. Let's do this quickly. 4 times 6 is 24. 24 add 3 is 27 over 4. Very quickly, 5 times 3 is 15. 15 add 2 is 17. 17 over 5. 10 times 2 is 20. 20 plus 9, 29 over 10. Pause the video and answer questions 8 and 9 in 4 minutes. Assuming you've paused the video and you've answered questions 8 and 9, here are the answers. Here you're asked to convert the improper fractions to mixed numbers. And very quickly, by now, you should know how that works. So to do this, we can simply say 7 divided by 2 is only 3 times because 3 times 2 is 6. So our remainder is 1. We write 1 out of 2. 19 divided by 6 is only 3 times. Why? 3 times 6 is 18. So 19 divided by 6 can only go 3 times. Our remainder is 1, so we write 1 6. 7 divided by 3 is 2. Our remainder is 1, so we write 1/3. 87 divided by 10 is 8. We can only get 8. We can only get 8 lots of 10 from 87. Our remainder is 7, so we write 7/10. Here we require to simply find the missing numbers, and here are the answers. Okay, let's move on. Answer question 10 in 2 minutes. Assuming you've answered question 10, here are the answers. So you're asked to complete the statement. 5/4 is 4. 5/4 is equal to 3, 9/4, and 2, 13/4. So you're asked, what did you notice? Well, the numerator increased by 4 each time because 4/4 is equal to 1 whole. And that's what is going on. Okay? 4/4 is equal to 1 whole. So each time, the numerator increased. And that brings us to the end of our lesson. So far you have learned how to convert between mixed numbers and improper fractions, and between improper fractions and mixed numbers. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.